Hi everyone. Today we're going to be looking at what is meant by the extremes of a function. So, in your notebook, please put down today's subtitle, which is the extremes of a function. Well, in this entire chapter, the extremes of a function must be the easiest single thing to identify. The extreme refers to the following. You are trying to identify the point on the range, and don't forget the range represents the y-axis. That is the completely highest point on the graph, we call that the maximum, and the point that represents the completely lowest point of the graph, and we call that the minimum. So let's take a look at this analysis with a very easy example. So please put EX. I would like you to take a moment to draw the following example. Go ahead, pause the video, and draw it now. Alright, let's take a look at this particular graph. So, let's first identify our maximum. So, on the right, please put down maximum. So, we are trying to identify which part on this graph represents the completely highest point on the y-axis. And if you take a look at the graph very carefully, you'll notice that the highest point, which I'm going to circle in blue color, occurs over here. That corresponds to the point y equals 3. And I don't think there's any point that goes higher than that. So, let's put that down in our conclusion. The maximum occurs at y equals 3. Now let's take a look at where the minimum occurs. So again, on the right hand side, please put down minimum. So to identify the minimum, we are looking for which point on the y-axis represents the absolute lowest point on this graph. And again, in a blue color, I'm going to circle where that point is. If you look at the graph carefully, I'm pretty sure that the lowest point occurs right here. I don't see any point that goes lower than that. So therefore, in our conclusion, we put down that the minimum of this graph is occurring at y equals -4. Now let's take a look at another example where one of them, either the minimum or the maximum, might exist, but the other one might not. So, please put down example. I would like you to take a moment to draw the following graph. Go ahead, pause the video, and draw it now. Alright, let's take a look at this particular parabola. Now, let's first try identifying our maximum. So on the right hand side, please put maximum. Alright, so again, we're trying to identify the absolute highest y coordinate on this graph. Again, using a blue color, I'm going to circle the highest point, and I believe it occurs right here. That corresponds to a y value of 3. So let's put that down in our conclusion. Y equals 3. Now, let's try to identify our minimum. So on the right hand side, please put minimum. Now, notice that this parabola keeps going down forever. There's no end to it. So in this particular case, it's impossible to tell what the lowest y value might be, because this graph never stops. So, in fact, we cannot tell what the minimum is. So in our conclusion, we can simply put that the minimum, there's none. And that's good enough for me. Now let's take a look at one last example, and it'll be an example where there's no maximum and no minimum. So, I'd like you to put example. I would like you to take a moment to draw the following graph. Go ahead, pause the video, and do it now. Alright, let's identify the maximum and the minimum for this particular graph. Now notice that this graph is a linear function and there's no end to it, going up or going down. So therefore, it's kind of hard to say what the maximum is because we have no clue where this line will stop. At the low end, it's hard to say where the minimum is because, again, we have no clue how low this graph will actually go. So for both the maximum and the minimum, we can put that there's none. So maximum, none, and minimum, none. And that's all there is to what is meant by the extremes of a function. You are looking for the absolute highest point on the graph and the absolute lowest point on the graph. And keep in mind, sometimes you could have one and the other, and sometimes you could have neither of them.